Hello everyone, welcome back to Nated Engineering. We are doing Forces Engineering Science N3 and we're looking at the trusses force, roof trusses to be specific. Roof trusses are a structural framework that is designed to support a roof. And we are talking about a structure like this. I know most of us has seen a structure like this before or a framework like this before. Roof trusses are designed to support two forces or two types of forces, which is the first one, a compressive force called a strut and is represented by this sign. And we have the second one, which is represented by this sign, is called a tie, and it is a tensile force. These are the two forces that are supported by a roof truss. So the job of an engineer when they are dealing with a project like this is to get all the forces that will be acting on the roof truss and then calculating the forces that will be acting on each member of the roof truss so that we know which material to use or which material to choose so that we have the best structure, which is exactly what we will be required to do in this section. What we'll be required to do is to calculate. They will give us calculate the forces of member BE and EF and then determine their nature. When they say determine their nature, they want you to tell us that either a compressive force or acting on this member. And that is exactly what we are going to do with this roof truss. So I'm going to move it to the side. The question for the structure that we see before our eyes says, calculate the axial forces in each part of the following framework and determine their nature, the nature of the forces. You will know when they're talking about that, they want to know if the force is a compressive force or a tensile force. And we use strut or tie as the term that we use in roof trusses. So the first thing that we have to do here is to determine the value of L and R since we are not given. So we are going to do them as we will do with a normal beam. This is L and we have R. We have a force acting here and that force is equals to, sorry, I forgot to put the angles here. It's 45 here. It's 45 here. Same thing. And it's 45 here. So this is in the middle. We can tell that from this point to this point is 4. Therefore, since this BE and EF are the same length, because we can see that they are the same angle here, we know that this 10 is in the middle, making the distance from L to this force 2 meters. Same thing with this one of 4 kilonewtons. So what? 2 meters. This is 2. And then in the middle we will be left with 4 meters from this point to this point. And then from here our job is to calculate what? The reactions. So first we are going to take moments about L, that will give us R is R times the distance from L to R is what? 8. I'm sure you know how to calculate reactions. And we're going to say the distance from this force to L is 2. They are going in the same direction with the 4 kilonewtons, therefore it's a positive. That is why they are in the same side of the equal sign. 4 kilonewtons times the distance from the 4 kilonewtons force to L is 6. And then from here, we do our calculations, and I got that our R, we know that we're going to divide both sides by 8. And our R, I got that it is 5.5 kilonewtons. That is our R, 5.5. We then take moments about R. Moments about R, L times 8. The distance between R and L is 8. It's equals to 4 times 2 plus 10. The distance between R and 10 is 6. We're going to divide both sides by the 8, which give us the value of L as 8.5 kilonewtons. It's 8.5. We can erase this now. We are going to start with part 1. Part 1 is where we have the reaction L. Let's take that structure out. We are having something like this, with this being L, and then we are having something like this being BE and this. So this is B, this is E, and this will be our A. The angle is 45. We are going to start with BE. The first thing that we have to do is to choose a direction for BE. That seems to be the one that keeps this thing in balance. So I'm going to say the direction for BE is towards this point. And then I'm going to say the upward moment are equals to, or the upward forces are equals to forces going down. We have a force that is going up, and that force is L. And we are going to say equals to a force that will be going down. We know when a force is applied at an angle, it develops two components. The component of BE that is going down will be BE sine 45. It's sine, we're using the angle that this force makes with the horizontal. So we're going to put it here. BE sine 45. We have L. L we calculated, we got it is 8.5. BE we do not have, that's what we are looking for. Sine 45. our BE will be equals to what? 8.5 divided by sine 45. And the answer that we are going to get here is what? Is 2.021 kilonewtons. The answer that we got is positive. That tells us that the direction that we have chosen is correct. If you choose a direction, you do calculations and then you get a negative answer. The answer is correct, but the direction is not correct. So if, let's say, we did this calculation and got a negative answer, we're going to keep the answer as the force that will be acting on that member, but we're going to change the direction to say, but the direction is in that, it is in that way, it's in that direction. So since this direction is correct, we come to BE and say the direction of BE is going towards this point number 1. And then we're going to mirror this direction at the middle of this member like this. We come back to this. We see that this symbol is the symbol that represents a strut, which is a compressive force. Therefore, if we were to be asked to calculate for the magnitude, this is the magnitude of the force that is acting on that member. The nature of the force, it's a strut. This is how we get it. But we are not done with this member. We have BE and we have AE. So we are going to say, let's put BE here. Say BE. We now have it. It's 2.021 kilonewtons, and the nature is a strut. Let's erase this. Now, since we are looking for AE, we are going to say forces to the left are equals to forces to the right. Forces going to the left are equals to forces going to the right. We have a component of BE, which will be the horizontal component. The horizontal component will be in that direction because the original force is pointing towards this point. Therefore, the component must also point towards this point. We know how to get those directions. So since this one is pointing to the left, we need to choose a direction for AE that seems to be the one that seems to be balancing the forces that we are having. So since this one is going to the left, we're going to say AE is going to the right. And you must understand that that is not the final decision, or that is not final, because we are going to use that direction to make calculations and prove if it's correct, or we will be proven wrong to say no, it's in that opposite, it's in the opposite direction. How are we proven wrong? If we get the answer with a negative sign. So I'm going to say the force that is going to the left hand side is the component of BE, which will be cos 45. To the right, I'm saying this is the one that's going to the right. It's AE. I'm looking for this. I have the value of BE. So our AE is equals to 2.021 cos 45. then our AE will be equals to BE, which is 2.021 cos 45, and that, according to my calculator, is equals to 8.5 kilonewtons. The answer is positive. What does that tells us? The direction is correct. We go to our structure and say the direction is correct. We mirror it. It's giving us something like this. And it's a tie. So we come here and say we also have AE with a magnitude of 8.5 kilonewtons, and it is a tie. Let's do it again. Let's do the calculations again, but now we are doing the calculations of point number 2. So we are going to draw the structure again. This is R. We have AG and we have DG. This is G, this is D, and this is A, angle of 45 degrees. And this is R. What do we do? We choose a direction for DG. And then we say upward forces are equals to downward forces. R is going up. The force that will be going down is the component of DG. It will be DG sine 45. We're using the angle that the force makes with the horizontal, therefore it's a sine because it's the vertical component. DG will be equals to R, which is 5.5 divided by sine 45. And that, according to my calculator, is equals to 7.778 kilonewtons. Let's say this one, kilonewtons. And it is positive, meaning the direction is correct. So we come to DG and say put the direction here and mirror it. This is what? It's a strut. So we are coming again here to say we also have DG, and it is equals to 7.778 kilonewton, and it is a strut. Now we have to calculate AG. We are going to erase this. forces going to the left are equals to forces going to the right. The horizontal component of DG is going to the right hand side. Therefore, we are going to say AG, let's point it to the left hand side. So we're going to say to the left is AG, which is what we are looking for, and to the right is the horizontal component of DG, which will give us DG cos 45. What is the value of DG? 7.778 cos 45. And according to my calculator, I got that the value of AG is equals to 5.5 kilonewtons. It's positive, therefore the direction is correct. We come and say it's like this, and this is what? It's a tie. Therefore we can come and say here we also have AG, it's equals to 5.5 kilonewtons, and it is a tie. We are done with point number 2. Let's do point number 3. Let's erase this and also erase this structure. We are doing point number 3. We did 1, we did 2, now we're doing 3. So we're going to draw the structure. Let's draw it here. This is the force. It's going down. It's 10 kilonewtons. And here we are having this member, which is PE. We're also having this member, and we're having this member is B, E, F, and C. So PE we already have the magnitude and the direction. It's in that direction. We do not have EF and CF. Yes, we do have this one. So we're going to start with forces going up. Saying upward forces are equals to downward forces. We have a direction for PE, but we do not have a direction for EF. So we have to choose a direction for EF. I'm going to say it is going down. The sum of the forces going down are equals to the sum of the forces going up. The force that will be going up is the component of PE, which will be BE sine 45. It's equals to 10 plus the component of EF. It will be EF sine 45. It's 45 as well, because we know that this one will be, what will be 45? And This one will also be 45 because of this line. And that 45 is what this EF is making with the horizontal. So our angle is 45. We have PE is PE sine 45. We have PE. What we're looking for will be EF. So I'm going to say EF is equals to sine 45. No, it's not equals to sine 45. EF sine 45 is equals to PS, and our PS is 2.021 sine 45 minus 10. And then we're going to divide both sides by sine 45, which will give us a value of EF as negative 2.121 kilonewtons. We have the magnitude, but it is negative. What does that tell us? It tells us that the direction that we have chosen is wrong. Therefore, we are going to correct the direction. The direction should be towards this point. Therefore, EF, where is EF? We place the direction here and then we mirror it. It's a strut. We can then ignore this when we are presenting the magnitude, because this was just to indicate to us that the direction that we have chosen is not the correct one. And then from there we have to get EF, CF rather. So I'm going to remove this. Oh, before we remove, let's record the value of EF. We come here and say we now have EF as well. It is equals to 2.121 and it is a strut. And then we can then erase this. Now we will be dealing with forces to the left are equals to forces to the right. First, for CF, let's choose a direction. I'm going to choose a direction that is going towards this point. And we're going to say forces going to the left hand side will be CF rather. And okay, let's write CF first. Plus, which one is going to the left will be the component of EF. We do have EF, so we are going to have 2.121 it's the horizontal component, so it's cos 45 here. It's equals to PE, the component of PE, cos 45. We are looking for CF. Let's make it the subject of the formula. And we are going to have PE. We know the value of PE is 12.021 cos 45 minus 2.121 cos 45. And this will give us our CF as 7 kilonewtons. And it is positive, therefore the direction is correct. So we come here and put the direction, mirror it. It gives us a what? A strut. We're going to say it's S. I'm going to leave point number 4 to you to do it yourself. You will be required to calculate for FG. The value of FG is 21.12 kilonewtons, and that's the final answer that you must get after calculating for it. And this is actually what this part of forces is all about. It's all about calculating the force that the member will be subjected to and the nature of the force, nothing more. So with that being said, I'm going to end our lesson here. I will see you on the next lesson.